Check this out. Last August, a wall of rock collapsed in Tracy Arm, Alaska. That's a fjord right there. It triggered one of the largest tsunamis ever recorded in the world. Now, this megatsunami is now the second tallest ever. Second tallest. University of Calgary's Dan Shugar joins me right now. He's an associate professor for the Department of Earth, Energy, and Environment. Doctor, thank you so much for joining me today. I appreciate it. Megatsunami, and it wasn't even caused by an earthquake.
Yeah, that's right. Just an unfathomably large wave that was generated. I can't imagine, how terrifying it would have been to be a fly on the wall there.
Yeah, tell me what exactly happened, because if it wasn't an earthquake, what did cause it?
So tsunamis are most typically caused by earthquakes, but just like jumping into a bathtub or a swimming pool, the displacement of water from that massive, injection of rock, if you will, into the fjord in this case, basically caused the same thing. One of the big differences, though, is that in a typical earthquake-triggered tsunami that occurs out in a subduction zone in the middle of the Pacific, the water can actually, the wave can travel outwards almost forever until it reaches land. But in the case of this fjord in Alaska, the valley walls of that fjord are so steep and so tight, so narrow, that the water really only has one way to go, and that's up.
Oh my gosh! I mean, how big was this thing when it peaked out?
So the highest point that we measured from satellite imagery as well as from a helicopter survey was 481 meters high. So that's 16 or 1,700 feet, something like that. Just a hard to understand, hard to contemplate number.
We're looking at the animation now, Doctor, and I can't even imagine how much rock and landslide displace this kind of water.
Yeah, in this case, the landslide itself was 64 million cubic meters. And so that's, ignoring the metric versus imperial,
Right.
That is enough rock to fill the Great Pyramid of Giza about 24 times.
Holy
so a tremendous amount.
That's a great way to picture it right there. That's incredible. That's amazing. What do you think caused the gigantic landslide?
Well, so landslides often have a specific trigger, like an earthquake or maybe very heavy rainfall, that sort of thing. But sometimes they don't. But they always have some underlying kind of preparatory causes that make that slope sort of want to slide. And in this case, one of the main factors, we think, was the retreat of the glacier at the bottom of the fjord there that you can see in the video. And in the last year or so, the glacier had retreated on the order of about 1,800 feet. Part of that was in the 2 weeks or so just before the landslide. So the glacier is retreating and kind of removing the support for that valley wall. And 2 weeks later, it slid.
It only took 2 weeks for that to all of a sudden come crashing down. That's pretty crazy.
Yeah, I mean, it was probably being set up by
right.
decades of retreat, but that the straw that broke the camel's back was probably that retreat in the couple of weeks prior.
That's amazing. Doctor, how fast was this wave moving? I mean, you said it was pinned in and it was only building upwards. What about the forward speed? How fast do you think it was going?
Faster that there's no way you could outrun it, no matter what kind of boat you're in. Something like 100, I think it was 150 miles per hour was what the model simulation, the computer simulations were suggesting that it was traveling. One of the computer animations there is sort of from the perspective of you on the water surface in a jet ski, as if you're traveling at something like 100 miles an hour, and the wave just overtakes you. And that's, I think, a critical issue for early warning. If we, the scientific community, had been able to warn of this event with an hour's notice, that probably wouldn't have done much.
Right.
But a couple of days warning, when we knew, or in hindsight anyway, when we knew that the slope was starting to break up, just those really early stages, that would have been enough time for any ships in the area to kind of get out of the way.
We just showed that video again. If you're trying to outrun it on a jet ski, all of a sudden, I mean, there's no way you could have done that, no question. So
no, and
yeah,
I think watching that, it's incredible. And, we can smile and kind of, laugh about it.
Right.
And I do the same. But, it's important to remember that if this event had happened, 5 or 6 hours later, it probably would have been a very different situation, disaster with hundreds of people killed.
Right.
Because this fjord is very popular with cruise ship traffic. Some of those cruise ships have literally thousands of people aboard. And, if they were up at the head of the fjord to look at the glacier calving, which is what they're there to go look at, I can't see any way that a ship would survive a wave like this.
No, in fact, our executive producer did take that cruise, went up the Tracy Arm in the fjord right there. So I know someone that's been there
No
for
kidding.
sure. So what about Dan? When you're up there now, what does the landscape look like? Did it carve away? Did it take any of the rock along with it?
So yeah, the 64 million cubic meters of rock that slid into the fjord, that's mostly now deposited on the ocean floor. The biggest change, if you were to sail up there today, the biggest change would be like that frame you just showed of the island with one tree on it. As this tsunami wave went out the fjord, it basically clear-cut the forest on the fjord walls in many places up to 100 meters, 350, 400 feet above the ocean surface. Basically like a gigantic lawnmower, going along the edge, just leveling everything in its path. And the trees here, you think those of your viewers that live in Washington, Oregon, or Alaska will certainly be familiar with the kind of forest that exists or existed in this part of Southeast Alaska. But for folks in, I don't know, Delaware or something like that, the trees here are large coastal rainforest trees. These are really big trees that to just knock them over like matchsticks is required a force that is hard to imagine.
I'm trying to imagine it right now as it travels right outside the fjord and goes into the water. How far did the wave travel, and was it detected anywhere else?
Yeah, so the tsunami itself, so in other words, the water level oscillation, was recorded at Juneau, which was something like about 70 miles away from the event. But at that point, it was only about a foot high. So, if you were down at the water, you would have noticed it, but it wouldn't have, caused much damage once it hit there. The interesting thing about this event, though, was, all this water sloshing around the fjord itself created a seismic energy that was recorded all the way around the world for about a day and a half.
Wow. Just the back and forth of the water was still shaking the ground.
Yeah, so it's kind of like if you fill up a cup of tea and it's a little bit too hot or too full rather, and you're kind of walking and you trip on your carpet or something, and the water in the tea sloshes back and forth. Similar kind of thing here, except we're talking a lot more tea.
That is fascinating. So all right, so this is the second biggest tsunami. Last question: what was the first biggest tsunami? If this was the second biggest one?
So the biggest was actually not that far away in Alaska. It was 530 meters high in 1958. And I'm going to do something unorthodox here, and I'm going to turn my screen.
Yeah.
And so this is a map from the late 1700s that was made by the very first European explorer who essentially, sailed up that in that part of the coast there. And that one was also triggered by a landslide, but in that case, an earthquake triggered the landslide, which then triggered the wave.
Got it. But it was still a lot of rocket thrown into one little shot of water, and then boom, you get this huge
Absolutely.
tsunami. That's amazing. Dan, what a great discussion. Thank you so much for coming on and sharing it with us, because, yeah, we just recorded the second biggest tsunami ever. So cool. University of Calgary's Dan Shugar. Thanks, Dan. Appreciate it. Thank you, Doctor.
Thank you.
Yep.